Hey, hello everyone. Thank you for joining me for this presentation that I titled Rapid Insights for Malware Analysts. So, first of all, I want to start thank you to saying thanks to the organization to select my talk. I know that they got really good papers and they decided to go with mine. So thanks a lot for the opportunity to present a tool that I called R2 Inspect. So to present myself, my name is Mark. I'm a cybersecurity researcher that is on the industry for the last 15 years. I'm on the field of malware analysis and also doing threat in intelligence. And the idea is or what I try to do is every time I'm creating a tool is to help everyone to speed up on their task throughout automation. So the problem I had, or every time every time we release a tool into the market, is to solve a problem that you have, and that's why the people that is on the field of creating tools or scripts or and then sharing them on GitHub is because those developments are solving problems, and that's why we decide to start creating one of those projects. And that's why I wanted to create R2 Inspect, because I had an issue on my daily malware analysis task that at the end of the day I was doing a lot of manual triage, repeating the same initial inspection steps manually. For example, checking headers or hashes, or maybe even stuff like similarity and stuff like that. So at the end of the day, if you don't have an automation, what you have is a lot of ad hoc scripts that are at the bottom line. What are them is scattered one-liner scripts without a unified structure, and then you have to parse these results and then do a lot of work, let's say, checking these outputs. Of course, if you don't have a framework, you will lack of standardization, and then even the results can vary between analysts and setups, because maybe on this system you are using this library to do XYZ, or maybe this version or this feature flag is available on Unix but not on Windows. So I mean, if you're on the field, you know what I'm talking about. It's also hard to reproduce, so you have a limited scenario when you can reproduce that, and it's hard to ensure that the same outcome will survive across the different runs. And then if you want to escalate this or to have this at a scale, it will be hard if you don't have a framework to do that. That is running consistent analysis, and then many samples could be challenging because of the structure. So you need something on as a tooling that will help you to achieve that. So basically, what I made with R2 Inspect is to make Radar 2 inspection structured and be able or easy to reproduce, and also be easy for you to share the result across the different teams or friends or whatever you are exchanging your time, your fun times of malware analysis. So maybe one of the smart questions could be, why is this tool supported by Radar 2? So, well, we are on the RadarCon, on the Radar 2 conference. I'm sure that all of you loves Radare and also the different tools that are available, like R2Pipe or other different tools that are out there. So basically, R2Pipe is the best engine nowadays to do malware automation, and you can basically use the Radar2 APIs directly for analysis and also for data extraction. R2Inspect it's coming to extend and not replace the actual tooling or scripts, because at the end of the day, what we have to do, or at least the open source flow that we should have, is to have the idea to complement existing workflows instead of reinventing them. It's built on the same philosophy as Radar2, so basically it's open source, it's scriptable, it's modular, and it's of course community driven. It has native compatibility because it's built on top of R2Pipe. And it can work with Radar2 commands, with also JSON. It has JSON outputs, and also it has support for plugins. The idea is to encourage the reproducibility, making the Radar2 results easier to share, to compare, and also to automate. So basically, R2Inspect exists because Radar2 made it possible with R2Pipe, with the R2Pipe engine. So what is R2Inspect? So R2Inspect is a reproducible inspection framework built on top of Radar2 and R2Pipe. The purpose is to automate binary triage and also extract the data in JSON, YAML, CSV, JSON lines, so it has different output formats for further analysis. The focus is consistency, speed, and integration even for a single binary, or even for large data sets. Like, for example, the latest data I made, it was for 35,000 samples on a folder. It has a modular design, so each inspection unit, like import sections, entropy, it is running independently, and it's an output first approach. So basically, it will has as an output a standardized structure, is machine readable, and is ready for scripting, for CI, or even for visualization. So in short, R2Inspect will turn Radar2 analysis into a structured, shareable intelligence for the malware analyst community. Some of the things that can be extracted by R2Inspect is metadata extraction, like format, architecture, hashes, size, entropy, but also permission, anomalies, entropy hints, the API usage, suspicious patterns, missing symbols. I also added signatures to detect packers, for anti-debug hints, for uncommon sections, but also keyword filtering and regex-based extraction for the strings inspection. Also, the possibility to count functions, to extract also complexity indicators, and also to detect even potential entry points for the complex and large binaries. As an output format, again, it's all released on JSON and YAML, but also it has support for JSON lines and also CSV. It can process entire directories with the batch mode using the CLI, and it will aggregate the results into a unique output file. R2Inspect can be easily extended, adding custom detectors or enrichers throughout Python. So which features are available? So basically, the workflow is you will have a binary, either a PE, an ELF, a macho, that will be passed to R2Inspect. Then we will launch a Radar2 session throughout R2Pipe using native commands. And then we have what we call inspection models that will be independent analyzers that will collect the data using R2Pipe and native RADAR2 commands that will extract the sections, the import, the export, the strings, the heuristics, hashes, entropy, and multiple other things. Then they will normalize the output and applying a normalization layer that we convert heterogeneous RADAR2 outputs into a unified schema. I implemented different exporters trying to cover all the different scenarios that you can face, like producing JSON, YAML, or CSV reports ready for scripting or to introduce them into a pipeline. And it's also possible to implement optional hooks, like for custom post-processor or for enrichment or for policy checks or whatever, let's say, stuff that you need for your workflow. So basically, the pipeline is you will have a binary or of a list of binaries. Then we will open them with RADAR2. Then we will inspect them with the R2Inspect models. Then R2Inspect will create an structured output, and then you will have actionable insights from the data that you analyzed. So from this list, this is documented also on GitHub. What I try to do, because it's something useful for me, I wanted to have all the hashing techniques or fuzzing techniques or similarity hashing techniques available in R2Inspect, because I have to usually compare large data sets to find similar samples. So I wanted to have a tool that collects all the fuzzing hashing techniques using on the backend R2Pipe with native RADAR2 commands in order to extract this information. So what I made is to read the papers and the different implementations that are out there, and I created these plugins inside R2Inspect to analyze my data set with my framework. And this is an example on the left about how you can create a new plugin into the system, so something really easy. As an output format, again, what I try to cover is all the possible scenarios. So from one side you have JSON, that is the primary structured output, and you can easily parse it with JQ or even with Python, or to index them in a CM, Elasticsearch, whatever you want to use. I also added the support for YAML, CSV, JSON line, but also Markdown and HTML. So please, if you need, and also has support for the Sheriff format. That is something that Pancake asked me to add, and I think it's good also to have this format into R2Inspect. So basically, as you can see, with this output format support that R2Inspect has, you will have this insights portable, and you will go from the CLI, so from the terminal, and you can even create or to build a dashboard that you can reproduce anywhere, because you have the raw data. A simple demo to showcase the tool. So basically what I have here is a folder with 100 samples that I will launch R2Inspect into the 100 sample folder, and then as you can check, R2Inspect is quite fast analyzing the entire folder. It will use parallel links to launch each module of inspection into the samples, and then after a few seconds we'll have the report in CSV to later analyze it. And if you want to check the format, we can check how much data is available on the CSV that you can process later with other tools, or you want to analyze it manually. So how we can extend the framework? So what I try to do with R2Inspec is to be a really modular project. So basically, each feature is implemented as an independent inspection module. So basically, what you have to do is to create a new Python class that will inherit from the inspector. You will have access directly to R2 pipes, so every model can call native radar2 commands or JSON APIs. You can create your custom logic, extracting and normalizing or even emitting findings with your own heuristics or metrics. So we are really modular here. You will have, or you can prepare automatic integration because the new models are discovered and executed dynamically at runtime. So this offers a lot of flexibility into the R2Inspec framework. It has a standardized output, so all models produce structured JSON entries for aggregation, and this is quite interesting for automate this at scale. So in order to extend the framework, what you have to do is to put the new model inside the R2Inspec/models folder, and then query radar2 through R2pipe to do whatever you need with the data extracted. You can implement your own logic to return extracted findings, and then register all of them in core.py, and it will be part of the R2Inspec pipeline. So another cool thing that you can do with R2Inspec is to integrate the library inside your current CI/CD schema or maybe your N8N workflow. So anything you can automate or to integrate in your pipeline, you can do it with R2Inspec. So basically, what we can do is, for example, to do a shift left approach that is quite common on the DevOps ecosystem, bringing the binary inspection into a build pipeline. So basically, R2Inspec is running in headless mode inside the CI environment, so you can integrate it in GitHub Actions or in GitLab or in Jenkins. It has a batch mode, so you can scan all the build artifacts automatically before the release. You can also establish some policy checks, for example, that you can force the build to fail in case the binary that you compiled it contains forbidden imports or writable sections or packers that are detected. I mean, you can do anything on your CI/CD schema, and you can produce JSON and YAML reports that can be parsed and also differed between builds. You can have continuous visibility and track compiler changes, size, entropy, or even do a function count over time for the different builds that you launched in your pipeline. You can also reuse the existing workflows because it's easy to integrate this tool, and also right now it's compatible with Docker, with Python virtualenv, or even with R2PM environments. So I try to do something flexible, modular, and also portable to be integrated in whatever place you need. So some of the use cases that you can do with R2Inspec. So first of all is the malware triage and clustering. So basically you can detect packers or samples with high entropy sections and even with readable anomalies. Then you can extract hashes like the im hash or ssdeep or TLCH for clustering or similarity scoring. It also supports unified JSON, CSV, JSON lines, easy to ingest into Python, Elasticsearch, or even MISP. So as I explained it, as I showcased it before on the demo part, we were able to process 100 binaries in under 30 seconds. So this is quite fast for someone that wants to automate this at the scale. let me show you a little demo. So in this case, we have a folder that is called results, that it has 100 JSON lines that we created with R2Inspect. These files will be from my data set, and then if I check the structure of one of them, I can see how I managed to create an structured and schema for the analysis. And then I prepared this query formats one-liner with JQ that you can do, for example, to check which hashes or which samples of your data set are packed because of the static analysis, how many imports it has on specific samples. The other query, it will be just a query to check or to extract a summary about the different hashes available in your dataset, like the IM hash or the SSL deep, or all the hashes that are available there. And the third use case is to do even a comparing table. So as you can see, when we have like a structured output, you can do later your Kung Fu terminal stuff to concatenate, to aggregate, to analyze the raw data to maybe seek for additional information or whatever. So basically, everyone that uses Radar 2, they want to be able to do this on terminal. We love the Unix style, so I wanted to follow the same philosophy with R2Inspect. So the second use case could be the possibility to check the integrity in the different builds, and also even to detect supply chain attacks or to validate the supply chain pipeline. So basically, we can detect forbidden API imports like virtuallog or load library, and then identify entropy or section changes between builds, and then force the pipeline to fail if automatically if some of the binary policies are violated. So this is an example with a demo. So what I made here is I created. We will use the same data set as before. So what I created is a list of forbidden APIs that shouldn't be present on my binary builds because they can be used for bad purposes. And then what I made is a simple Python script that will check the policies against the raw results that I extracted by using R2Inspect. So basically, this Python will parse the JSON. So what I do here is to launch the Python script against all the JSON files that are close to 100 samples. And as you can see, in all of these samples are using the forbidden APIs that I say that won't be present on the build. So this can be also used as a part of your pipeline. Another thing that you can use as a final example is the use case 3 that is called threat intelligence enrichment. So basically, you can extract a structured indicator of compromise like hashes, import sections, and then feed directly this information into a CM, into a MISP, or into a custom threat intel dashboard. And also you can do crazy things like enable MITRE attack techniques correlation from static indicators. So this is not just inspection, it's intelligence that you can plug anywhere. So let me show you a demo. So you can see here the result, the same data set that I'm using before. And then I prepared some special queries for the raw results. So first of all, we will extract all the common hashes from a specific JSON dataset extracted by Earth2Inspect. The second example is to find samples that are capable to do process injection on execution, and that's why I'm seeking for samples that has these suspicious APIs inside the code that were extracted by Radar2. And then I want to extract all the suspicious imports from the files that I have on my database, and saying that the score will be like high or medium or critical based on the different imports that the binary has. And then the fourth is if you want to aggregate the results into a third-party system for data consuming. You can also export the file in CSV in order to be able to ingest it in other tools. Let's talk about performance and limits. So I'll try to, because at the end of the day, this tool is prepared to analyze thousands of files at the same time. So what I created is a memory-aware analyzer that will have real-time control. I implemented an automatic garbage collection that will be triggered dynamically when the usage exceeds the 75% of the allocated limit. So it will automatically clean up the garbage. I implemented some safety thresholds, like, for example, 2 gigabytes at max per process memory. You can change that if you want, if your system has higher capabilities. I also put another safety that is 512 megabytes per file, also 100 megabytes per section, and also 50K strings, and also 10K functions that you can analyze with Earth2Inspect. I guess it's enough to cover most of the cases, but if you think that these thresholds should be modified, just let me know. It also has some fail-safe behavior for large or corrupted files that are skipped gracefully instead of crashing the entire analysis. It has an adaptive analysis depth that is configurable fast and deep modes for triage or full inspection. It has also resource reporting, like the peak memory and CPU time are logged for profiling. So if you want to check the speed and the CPU usage of your analysis, and you want to improve what I do, I mean, really welcome to have a pull request that will solve some of the current issues or some of the possible issues that you can face if you run Earth2Inspect into really large data sets. The idea is to have a tool that can scale really well in batch mode, and that's why I implemented this memory-aware analyzer that will be checking if we are exceeding at some point the resources that the machine has. So the roadmap of Earth2Inspect is quite straightforward. So the idea is to unify even more the findings across import sections, entropy, and packet detections. The idea is to improve detection for virtualization, obfuscation, and in-memory loaders as well. I want also to improve the dynamic plugin loader, allowing external analyzers to register automatically without touching the core of Earth2Inspect. The idea is to improve the scoring system and generate a risk score per binary, or even for suspicion. Like, imagine that. So the idea is to have an independent score per analyzer, and then be able to come up with all of that together to even have I don't know, like different scores for the packers or the sections that a binary can have. The idea is also to improve the reporting templates, exporting to even more pretty HTML templates or Markdown files, and also to be able to create really nice dashboards that can showcase the data on a nice way. The idea is to improve also the parallel processing, multi-processing large-scale data sets with the batch analysis with memory safety. I also plan to create a REST API that can be used as a service to integrate it in your own project. And the idea also is to unify the validation of the new models, hashes, and performance metrics. This part that is never done on the development projects that you are lacking of testing and benchmarking. So why you should be an R2Inspect users? You need to be an R2Inspect user if you want to do a fast triage and get structured insights from binary in seconds. I know you love Radar 2, so this is built on top, so we have a lot of power and flexibility to do whatever we want. We can reproduce results made by analysts with the same output every time. So we can share this with our team that every time we will have the same format. We can index all the files into CMs or other tools because it has a structured schema. It's modular, extensible, and it's easy to add this R2Inspect project in your own detectors or your logic analysis, and even it's easier for you to add your own the heuristics or models inside R2Inspect to be used. Also, I want to have the project to be more prepared for CI/CD environments because sometimes you want to add this binary analysis part inside your build process. The intention is to have something like lightweight and cross-platform that can work anywhere where Radar 2 actually is working. We know that Radar can be executed inside even a coffee machine. So the idea with R2Inspect is it have the same compatibility running and be able to run it on Linux, on macOS, and on Windows. The idea is to follow the same philosophy as Radar 2 and be a community-driven project. We need something open source, transparent, and constantly evolving. So to finish this presentation, let's go with the conclusion. So R2Inspect will bridge automation and analysis. It will bring a structure and reproducibility to binary inspection without losing the Radar 2 flexibility. It has a practical impact, so the idea is to have a faster triage, scalable workflow, and reliable results across analysts and pipelines. It's designed for collaboration. It has consistent outputs that teams can share between them, can enrich the results, and also build something on top the results that are generated by R2Inspect. It's a community-driven evolution project that is open, extensible, and aligned with the Radar 2 philosophy. And the next steps is to continue expanding modules, heuristics, and integrations to make large-scale binary intelligence accessible to everyone. So R2Inspect isn't just a tool; it's a framework for reproducible insight built on the spirit of Radar 2. So thanks a lot for your time. I hope you find out this project interesting for you. So the pull requests are welcome, and any question I can check the chat later. Thank you. Have a good day.